Questions began circulating almost as soon as the light vanished. Why did a blazing fireball appear above one of the most seismically notorious regions in the United States? Why did thousands of people across nearly half the country witness it at the same time? And why did its path seem to trace a corridor that passes over the Mississippi River and the shadow of the new Madrid fault system below? As reports poured in from state after state during the late hours of June 14th, 2026, a familiar pattern emerged. A rare celestial event had captured public attention, and almost immediately another question followed. Was it merely a coincidence, or was it some kind of warning? The answer depends largely on whether evidence exists for any connection at all. Late on the evening of June 14th, residents across a broad section of the United States looked skyward and saw a brilliant object racing through the atmosphere. Witness reports arrived from numerous states stretching across the Midwest and parts of the South. Security cameras recorded it. Specialized meteor monitoring systems captured it. Social media feeds filled with videos and photographs. Within hours, the event had become one of the most discussed astronomical sightings of the month. According to data compiled from eyewitness reports and camera observations, the object first became visible above northeastern Mississippi before continuing northwestward across the sky and ultimately disintegrating high above Missouri. More than 500 witnesses submitted observations, making it one of the most widely observed fireball events of the year. The timing alone guaranteed attention. The region crossed by the fireball is not merely a geographic corridor. It is also home to one of North America's most closely watched seismic zones. The new Madrid Seismic Zone stretches through portions of Missouri, Arkansas, Tennessee, Kentucky, Illinois, and neighboring areas. It is remembered primarily for the historic earthquake sequence that struck during the winter of 1811 and 1812. Those earthquakes remain among the most powerful ever documented in the continental United States. Even today, the name New Madrid carries a unique weight. It evokes memories of massive ground shaking, altered landscapes, damaged settlements, and reports of the Mississippi River behaving in ways that stunned observers of the era. Scientists continue to monitor the region because earthquakes still occur there regularly, although most are too small to be felt. Against that backdrop, a fireball passing overhead was almost guaranteed to trigger speculation. The astronomical event itself was extraordinary. Data gathered by monitoring networks showed that the object entered Earth's atmosphere at roughly 56,000 miles per hour, or about 90,123 kilometers per hour. Despite traveling hundreds of miles through the atmosphere, the object itself was surprisingly small. NASA estimates indicated it measured only about 3 inches, or 8 centimeters across, and weighed roughly 1 pound, or 453 grams. Yet its speed transformed it into a spectacular streak of light, visible across a vast area. At peak brightness, it shone approximately 16 times brighter than the planet Venus. Its journey began at an altitude of approximately 60 miles, or 96 kilometers, above the vicinity of Tupelo, Mississippi. From there, it traveled about 300 miles, or 483 kilometers, before completely disintegrating over Missouri at an altitude of roughly 34 miles, or 54 kilometers. No meteorites reached the ground because the object was simply too small and too fast to survive atmospheric entry. That conclusion is important because many observers initially wondered whether a fragment might have landed somewhere near the Mississippi River corridor. Available data indicate that nothing substantial survived the journey. The fireball burned itself out entirely in the atmosphere. Still, the location remained impossible to ignore. Maps of the fireball's track show a path extending from Mississippi toward Missouri, crossing territory that includes portions of the broader New Madrid seismic region. The Mississippi River, one of North America's defining geographic features, also lies within this corridor. To many observers, the alignment seemed too striking to dismiss without at least asking questions. Questions, however, are not evidence. The temptation to connect unusual events is deeply rooted in human behavior. When something dramatic appears in the sky above a region already associated with geological risk, the mind naturally seeks patterns. Throughout recorded history, comets, meteors, eclipses, and other celestial events have frequently been interpreted as signs of coming disasters. Ancient civilizations often regarded bright objects crossing the heavens as warnings of war, famine, political upheaval, or natural catastrophe. The modern era has not entirely eliminated that tendency. Every time a major meteor appears, internet discussions quickly fill with theories. Some speculate about impending earthquakes, others suggest volcanic eruptions. Still others imagine hidden physical processes linking events in space with events beneath Earth's surface. The June 14th fireball generated many of the same reactions. Part of the reason lies in timing. The fireball was highly visible and arrived without warning. Unlike scheduled astronomical events, meteors do not announce their arrival in advance. A bright fireball can transform an ordinary night into a memorable spectacle within seconds. Because it appeared over a region already familiar to millions of Americans through earthquake history, the event acquired an added layer of intrigue. Yet examining the facts reveals a much simpler explanation. The object was almost certainly a small fragment of a larger asteroid. As it encountered Earth's atmosphere at extreme velocity, compression of air in front of it generated intense heat. The resulting glow produced the brilliant streak seen from the ground. The process was entirely atmospheric and followed the same physical principles responsible for countless meteors observed throughout history. Importantly, the altitude of the event remained extraordinarily high compared with the depths associated with tectonic processes. The fireball first appeared around 60 miles above Earth and ended its visible journey more than 30 miles above the surface. By contrast, earthquakes in the New Madrid region originate within Earth's crust at depths measured in miles or kilometers below ground level. The two phenomena occurred in vastly different environments, separated by enormous vertical distances. That distinction matters because speculation often assumes a direct interaction where none exists. The energy involved in a meteor entering the atmosphere is real, but its effects are generally confined to the atmosphere unless a sufficiently large object survives to strike the ground. In this case, available evidence indicates complete disintegration long before any material reached Earth's surface. Historical records provide additional perspective. Bright fireballs are not exceptionally rare. Several significant events have occurred across the United States during recent months alone. Early June witnessed another widely observed meteor over the Midwest. A separate event over the northeastern United States generated loud booms and considerable public attention after an atmospheric explosion released substantial energy. Neither event produced any demonstrated connection to major seismic activity. The June 14th fireball therefore joins a long list of atmospheric events that attracted attention without corresponding geological consequences. Yet the New Madrid connection continues to fascinate observers because of the fault's reputation. Unlike some fault systems marked by obvious mountains or visible fractures, much of the New Madrid Seismic Zone lies hidden beneath sediments and river deposits. Its presence is known primarily through seismic monitoring and geological evidence. This invisibility contributes to its mystique. People know the fault exists, but they cannot easily see it. A fireball overhead changes that dynamic. For a brief moment, something dramatic became visible above a region associated with something invisible below. The contrast naturally encourages comparison. Geographically, the Mississippi River corridor has long served as a focal point for natural phenomena. Floods, severe storms, earthquakes, and unusual atmospheric events have all shaped public perception of the region. When a meteor traces a path across the same landscape, it becomes easy to imagine a larger connection. The available data, however, point toward coincidence rather than causation. The fireball's trajectory was determined by orbital mechanics and atmospheric entry conditions. The New Madrid fault exists because of tectonic stresses operating within Earth's crust. These are entirely different systems governed by different forces and different timescales. One involves a tiny asteroid fragment encountering the atmosphere after traveling through space. The other involves geological structures that have evolved over millions of years. Their intersection over the central United States on June 14th appears dramatic, but drama alone does not establish a relationship. The scale of public interest, nevertheless, reflects the enduring fascination people have with both space and earthquakes. Eyewitness reports arrived from numerous states. Videos emerged from Missouri, Arkansas, Mississippi, and surrounding areas. Online discussions rapidly expanded as viewers compared observations and attempted to reconstruct the object's path. Some described green hues. Others emphasized the extraordinary brightness. Many simply expressed amazement at witnessing an event so unusual. For many observers, it was likely the brightest meteor they had ever seen. That reaction is understandable. Most meteors are faint streaks visible only under favorable conditions. A true fireball is different. Its brightness can rival or exceed the most prominent objects in the night sky. Such events leave lasting impressions precisely because they are uncommon enough to remain memorable, yet common enough to occur somewhere on Earth every year. The June 14th event also highlighted the growing role of technology in documenting transient phenomena. Only a generation ago, reports would have depended largely on eyewitness accounts. Today, security cameras, dashboard cameras, meteor monitoring networks, smartphones, and automated astronomical systems create a far more detailed record. Multiple camera systems captured the fireball, allowing analysts to reconstruct its trajectory with considerable precision. As a result, there is far less mystery surrounding the object's physical characteristics than there might have been in previous eras. Its speed, approximate size, altitude, brightness, and path have all been estimated using observational data. That leaves a different kind of mystery, the psychological one. Why do celestial events and earthquakes become linked so readily in the public imagination? Part of the answer may lie in uncertainty. Earthquakes remain among the most difficult natural hazards to predict. Because people cannot know exactly when a major earthquake will occur, unusual events often acquire symbolic significance. A meteor crossing the sky above a famous fault zone feels meaningful even when no physical mechanism supports the association. History offers countless examples of this tendency. Before modern astronomy, bright celestial events frequently became attached to major historical developments simply because they occurred nearby in time. Comets were linked to political changes. Meteors were associated with battles. Eclipses became omens. The same pattern continues in the digital age, although now it unfolds through online discussions rather than ancient chronicles. The June 14th fireball demonstrates how quickly that process can occur. Within hours of the event, questions emerged regarding possible links to the New Madrid fault. The questions themselves are understandable. The challenge lies in distinguishing curiosity from evidence. At present, no publicly available observations indicate that the fireball altered stress conditions along the fault, triggered seismic activity, or signaled any impending earthquake. The fault continues to behave according to the same geological processes that existed before the meteor appeared. Monitoring networks remain active. Seismologists continue tracking earthquakes. Astronomers continue tracking meteors. The two activities intersect geographically from time to time because both occur on the same planet. That reality may be less dramatic than theories suggesting hidden connections, but it is supported by the available facts. Even so, the event remains remarkable. A fragment only a few inches wide crossed approximately 300 miles of sky, became brighter than nearly every object visible at night, drew reports from hundreds of witnesses, and captured attention across a large portion of the United States. Not every day brings a spectacle visible across so many states. The fireball also served as a reminder of Earth's place within a dynamic cosmic environment. Small pieces of asteroids encounter our atmosphere regularly. Most burn up unnoticed over oceans or remote regions. Occasionally, one arrives at the right time, along the right path, above populated areas, and becomes a shared experience for thousands of people. That is exactly what happened on June 14th. The coincidence of its route over the Mississippi River corridor and portions of the New Madrid region transformed a routine astronomical event into a topic of national curiosity. Yet the available evidence indicates that the coincidence remains exactly that, a coincidence. The meteor arrived from space. The fault remains in the crust. The fireball burned out high above Missouri. The New Madrid Seismic Zone continues its slow geological evolution below. For now, the most compelling aspect of the event is not an omen of something approaching. It is the fact that a tiny asteroid fragment, weighing about as much as a household object and measuring only a few inches across, briefly illuminated a huge section of the United States and reminded millions of people that extraordinary sights can appear without warning in the ordinary night sky. Another reason the event attracted such widespread attention is the unique position occupied by the New Madrid region in American geological awareness. Unlike California's famous fault systems, where visible mountains, scarps, and frequent seismic headlines remind residents of the risks around them, the New Madrid Seismic Zone exists largely out of sight. Most people who live within the region rarely experience significant earthquakes. Yet the historical record ensures that the fault is never completely forgotten. The earthquakes of 1811 and 1812 remain central to that reputation. Contemporary accounts describe church bells ringing hundreds of miles away, extensive ground deformation, and shaking felt across enormous portions of the young United States. The exact magnitudes remain subjects of ongoing scientific analysis, but there is little disagreement that the sequence represented one of the most significant seismic episodes ever recorded east of the Rocky Mountains. Because of that history, almost any unusual natural event occurring in the region tends to attract additional scrutiny. A bright meteor over an ordinary location might remain simply an astronomical curiosity. A bright meteor over a region associated with one of the most powerful earthquake sequences in American history becomes something more. It becomes a topic of speculation, discussion, and sometimes concern. Yet one of the most striking aspects of the June 14th event is how effectively modern observation systems removed uncertainty from the event itself. Within hours, multiple independent tracking networks had reconstructed the object's path. Cameras positioned hundreds of miles apart captured the fireball from different angles. These observations allowed analysts to estimate not only its direction and speed, but also its approximate size and altitude throughout its flight. Such precision would have been unimaginable to observers a century ago. In earlier eras, a fireball of similar brightness might have generated weeks of rumors. Reports from different towns would have varied widely. Some witnesses might have claimed it landed nearby. Others might have insisted it exploded directly overhead. Stories would have grown more dramatic with each retelling. Instead, the June 14th fireball was mapped with remarkable accuracy. The object entered the atmosphere over Mississippi, crossed portions of the Midwest, and disintegrated over Missouri. The event lasted only seconds, yet enough data were collected to reconstruct its journey across approximately 300 miles, or 483 kilometers, of sky. That reconstruction is significant because it highlights a broader reality about modern science and public perception. Many natural events appear mysterious at first because people encounter them unexpectedly. A flash in the sky, an unusual sound, a tremor beneath the ground, or an unfamiliar atmospheric phenomenon can easily seem extraordinary when experienced without context. Once measurements become available, however, much of the mystery often disappears. The fireball's route over the Mississippi River corridor is a perfect example. The path appears remarkable because people naturally focus on locations they recognize. The Mississippi River is one of the most famous geographic features in North America. The New Madrid Fault is one of the continent's most famous seismic zones. A meteor crossing that region creates a memorable association. At the same time, the central United States covers an immense area. Meteors regularly pass over populated regions somewhere across the country. Statistically speaking, some of them are bound to cross areas associated with earthquakes, volcanoes, rivers, mountain ranges, or other notable landmarks. The coincidence becomes memorable because of where the meteor appeared, not necessarily because the location influenced the meteor itself. This distinction is important when considering claims that celestial events may serve as warnings of impending disasters. History demonstrates that earthquakes occur with no visible fireball beforehand. History also demonstrates that countless fireballs appear without any major earthquake following them. If a meaningful relationship existed, consistent patterns would likely emerge over time. Instead, the historical record shows that bright meteors occur across the globe every year while major earthquakes continue to follow their own geological timelines. The June 14th fireball therefore occupies an interesting position. It was rare enough to be newsworthy, but not rare enough to suggest something unprecedented. It was dramatic enough to capture public imagination, but well understood enough to fit comfortably within established astronomical knowledge. Perhaps the most revealing aspect of the event is how quickly attention shifted from the meteor itself to the landscape below. People were not merely asking what crossed the sky, they were asking where it crossed the sky. That subtle difference transformed a straightforward astronomical event into a broader conversation about geology, risk, and coincidence. The new Madrid Seismic Zone continues to fascinate Americans precisely because it represents a low-frequency but potentially high-impact hazard. Major earthquakes are infrequent there compared with some other seismic regions. As a result, long periods of relative quiet can make any unusual occurrence seem more significant. A fireball overhead naturally feeds that perception.